So for this sample problem, the given support, both ends are pin support, so therefore the K is equal to 1.0. So to get the ratio, the slenderness ratio, so K is 1.0. The length is given 6 meters, so we need to convert it to 6,000 mm. Then the radius of gyration. So take note, the given here is only the moment of inertia and the area. We can get the radius of gyration by taking the square root of I over A. So dito by inspection, yung recommended na radius of gyration is yung makakapagbigay ng malaking value dito sa slenderness ratio. So kukunin natin yung IY kasi siya yung maliit na value. So to get this the radius of gyration, 61.6 times 10 raised to 6 over the area 15,500. Square root of 61.6 over 15,500. So equals to 63.041 mm. So what is the ratio, slenderness ratio? So 63.041, 95.176. Then compare it to 4.71 so that we can determine kung anong formula yung gagamitin for FCR. 4.71 square root of 200,000. The given Fy here is 345. Therefore, 113.403. So, lumabas class is less than yung slenderness ratio natin. So, mag-fall siya sa condition 1 or inelastic buckling. So, FCR here is 0.658. Fy is 345. Fe, so solve natin yung Fe. Pi squared times 200,000 over the slenderness ratio na 95.176 squared is equal to pi squared 200,000 or 95.176 squared. So equal to 217.909 MPa. 217.909 times 345. So we get 345 over times 345, we get 177.83 or 84 MPa. For actual load, so Pn is equal to Ag times FCR. So the given gross area is 15,500 times FCR times FCR. So then divide it to 1,000. So 2,756.515 kilonewton. Then applying the design philosophy ASD and LRFD. So LRFD 0.90 times 2,756,515 is equal to times, so I will store it to A para magamit natin 0.9. So 2480.86 4 kilonewton for ASD. So we have to divide it by the safety factor 1.67. So A over 1.67 is equal to 1,650.608 kilonewton. So these are the final answers for item number 3. Then next is the sample problem number 4. A W305 by 87, 7.5 meters long. Ito yung ito yung length natin. Then is pin. So let's draw the figure. Draw the figure. It is pin at both ends. So pin siya, both ends. And brace in the weak direction at the third point. So third point, so ibig sabihin mahati ito ng tatlo. Sa tatlo. Kasi may bracing siya. So pag may bracing class, yung tatandaan nyo, yung support niyan is pin connection. So naka-pin connection siya. So what is brace in the weak direction? Nasa pin. Pag weak direction, related yan dun sa moment of inertia ng y-axis, about y-axis. So ito yung third points na may bracing. So mag-a-act yan as pin connection pag may bracing. Determine the available compressive strength. First is to solve for the radius of gyration since hindi po given. So use the square root of I over A. So gagamitin natin is yung smaller. Try natin to. Then yun, KL. So yung makukuha natin. So try din natin isolve yung Y and RY. Ito yung RY. Then ito yung RX. Ito IY, IX. So unahin muna natin yung RY. So 55.78 times 10 raised to 6 over 10,965 is equal to square root of 55.78 times 10 raised to 6 over 10,965. 71 yung radius of gyration for RY. Then yung IX natin is 331.2 times 10 raised to 6 over the area. So equals to what? 331.2 times 10 raised to 6. 10,965. So 173.796. So sabi ko 'di ba kanina yung pipiliin yung radius of gyration is yung maliit. Pero dito iba na po yung scenario kasi meron ng bracing. So yung magiging length sa KL, So, dalawa yung makukompute natin. Yung KL, then RY. So, yung K natin, pagka both pin support, so, unahin natin yung sa RY. Yung i-consider nito class is itong nasa third points, itong length lang ng weak direction. So, hindi siya yung buo. So, dyan may nakakabit na kasing another support. So, yan lang yung length niya. So, K is 1.0. Then, yung length niya is, ano yung magiging length nito? So, i-divide nyo to sa, yung buong length, i-divide nyo sa 3. Kasi ito yung magiging length na ng weak support, weak direction I mean. So, 7.5 divide 3. So, 3.52, 2.5. 2.5 siya. Ito, 2.5. 2.5 meters. 2.5. Then, yung buong length niya is 7.5. Para po sa weak direction, ang naapektuhan dyan is yung moment of inertia about y-axis. Ang i-consider nyong length is di 2.5. So, 2,500 over yung ry na 71.324. So, 1.0 times 25 over 71.324. So, 35.051. So, tingnan natin kung may mas mataas pang value ng slenderness ratio considering naman yung Rx. So, yung K dyan also equal to 1.0 kasi both pin support din, dulo to dulo. Then, yung length naman, so walang support na nakakabit dun sa strong axis or yung sa IX. Kaya buong length po yung i-consider natin. So, 7,500 over yung Rx natin na 173.796. So, equals to 173.796 equals to 43.14. So, lumabas class na mas mataas itong slenderness ratio kung saan yung Rx ang nag-govern, no? Ito yung gagamitin natin. So, use this. Then, compare natin dun sa 4.71 square root of E over Fy. So, ano yung E natin? 200,000. Yung Fy given ba? So, hindi na given. So, assume natin yung Fy na given is 248. Kasi nakalimutan i-given. So, ilagay ko na lang 248. 4.71 square root of 200,000 over 248. So, 133.755. So, less than yung slenderness ratio natin. So, condition 1 siya babagsak or inelastic buckling. Then, solve muna natin yung FE para makuha natin yung FCR. So, pi squared 200,000 over yung slenderness ratio na 43.154 squared. So, 200,000 over 43.154 squared. So, ang taas. So, 1,059.995 MPa. So, store ko lang to sa A. Then, yung FCR natin is equal to 0.658. So, masyadong malakas yung section. Gawa ng maliit lang yung slenderness ratio niya. So, malakas siya. So, Fy is 248 over 1, 059.955 times 248. So, FCR is 658,248 over A. So, equals to 224.865 MPa. Then, the action load is AG times FCR. Yung given na area dito class is what? 10,965. Then, divide it to 1,000 para maging kilonewton. So, 2,465.643 kilonewton. Next. Yan na ba yun? So, wala namang binigay na design philosophy. So, yan na yung final answer. Pero in case class, kunwari, yung given, so banggitin ko na, kung given na support is, isa is pin, at isa is, alin? Ang isa naman is fixed, tapos na, merong, then, nahati siya, or may support dun sa middle point nung column sa weak direction. So, makukonsider mo yung bracing as pin support. So, mag-a-act siya as pin support. So, makukompute mo dito, dalawa yung makukompute mo ditong KLRY, KLRY. Kasi, yung K dito sa taas is both pin, kaya 1.0. While for this one is, ano po, pag pin, yung isa is pin and isa is fixed, di ba yung K as per provision is 0.7. Then, i-check nyo kung alin sa dalawa. Then, may isa pa. Yung buong section. Kung buong section, yung KL over RX, yung strong axis niyan, so wala dyan talaga nakakonect na bracing kasi strong na siya. So, imagine niyo yung ganito, yung section mo. Ito yung top view. Then, may nakakonect dyan na bracing yan. So, yung sinasabing weak support po, weak direction is ito, nandito. Kasi, prone siya sa bending. Pwede siya mag-bend ng pag ganito. Kaya, dyan nilalagay yung bracing. No? Dyan kadalasan nilalagay. Para maiwasan yung pag-bend laterally. Then, dito naman sa weak, sa strong axis, ito. Dito sa direction na to. So, mahirap siyang i-bend. Kaya wala dyan nilalagay na support. Kaya yung kinoconsider po dyan is yung buong length. Okay. So, that ends our sample problems for this topic.